Okay guys, welcome to another video, and in this video we will be looking at operators. So we want to quickly consider the operators that we have in Python and see what we can do with them. Okay, we want to see some basic operations we can apply or perform with the data we have or we want to work with. Okay, so let's jump into it without further ado. So far you will be able to say that the previous video have been made very simple with light exercises, which is very important that you don't miss them. Okay, so we continue in that flow, keep it simple, and then we keep getting making progress as we go. All right, so the first one we have here, we'll take it one after the other, and then we'll explore with some examples. The first one we have here is arithmetic operator. We have a plus, which is addition. We have minus, which is subtraction. We have the asterisk sign, which is for multiplication. We have the forward slash, which is for division. We have the double forward slash, which is for floor division. We have the modulus, the percentage symbol, which is for modulus. And we also have the double asterisk, which is for exponential operation. Okay, so that means Python lets us do some basic maths like add, subtract, modulus and all of those things. So let's see it in action and see practically with some examples. All right, down here I'll just create two variables. Say first one, num1 will be 25, num2 will be 7. Add a new cell. Now we'll do num sum as the number sum, the addition of the numbers. I want to say is equals to num1 plus num2. Okay, so I'll run this and this will throw an error. Okay, so let's print it. This should throw an error, and I want you to look at it carefully and figure out what the error is. Okay, very important that you can do that. All right, I think some operation have been done here before, so I will restart the session. So interrupt execution and restart the session. Yep. So it says, are you sure you want to restart the runtime? Runtime states including all local variables will be lost. And yes, that is exactly what I want to do. Okay. So somehow at some point, one has been declared somewhere before. So run this again. Okay, I have to restart again. So come here, restart our session. Yeah, I'm sure I want to do that. So let's wait for it to restart. Done. So we'll run this again, and yes, it's showing this error. Now what does the error say? It's saying, hello, I don't know num1, I don't know what that is. And why is it saying that? That's basically because we have not executed this code cell. And how do you know when you have not executed the code cell? The square bracket will be empty. Okay, so we have to execute this first. So come here, execute that. All right, and then we'll execute this as well. So this is what we have, 32. So the addition of the two numbers are 32. So I'll add a new cell to the bottom. I think I might need a few more. Let's just add a few more. Okay, so we'll come back here and say num sum is equal to num2 plus 17. Now if we execute this, it will overwrite what we originally have. Okay, it will overwrite what we originally have, and probably that's not what we want to do. Let's say you probably want to add to whatever is in num sum already, which is 32. We want to add a new value, which is 17, with another value, which is 7, which is num2, to it. However, if we run this, you see we get 24 because num sum, that's 7 plus 17, is 24. So what is the workaround? So it is important that you understand all of these things so that you don't accidentally override the variable like that. So I'll re-execute this so that we have 32. Now, since we already have 32 existing in here, to make Python understand, we have to say, again, num sum equals to num sum plus. So we're saying num sum plus num2 plus 17. So whatever is in there before, we're adding this to it again. So we're basically saying current value of num sum plus num2 plus 17 should be added up and put inside the variable num sum. So I'll run that now, and you can see that we have 56. Okay, now we have 56. Nice. All right, so let's just do some quick prints so that we can move away from the arithmetic operators, as they are straightforward and simple. So we want to use formatted string. So say num1 plus num2, then we'll put a colon, and then we'll do our operation in here, num1 plus num2. Okay, we've done addition already, so we'll just do subtraction, Control C, Control V. I didn't mean to run that yet, but it's okay. Okay, let's start with this. So this is subtraction. Then we have division. So this also will be division. This will be floor division. This will be asterisk. This will be double asterisk. This will be modulus. That's in pretty much of what we have. Yep. So that's all that we have. So I'll take out the last one. And then come here. This is modulus. This is exponential. This is multiplication, floor division. So what does subtraction do? Of course, it subtracts the first number minus the second number. For division, it divides what is num1. Do not forget the value of num1, 25 divided by 7. That is what we get. And floor division takes out the decimal part of our division. Okay, floor division takes out the decimal part of our division. Then for the multiplication, of course, it just multiplies it, basic mathematical multiplication. So in this case, it will be 25 in 7 places, right? Or you say 7 in 25 places, still the same thing. Okay, and then we have the exponential, which will be 25 raised to the power of 7. And we also have modulus. So we're saying modulus is where you get the remainder of a division operation. Okay, so we get the remainder of a division operation. That's what we get. So let's execute it to see what we have. You can see we have 18, which is num1 minus num2. The division is 3.57, and you can see in this case the decimal part was cut off. Okay, the decimal part was cut off, and this is for multiplication, and this is for the exponential value, and this is into first figure, second 3. So I think this is about a billion. So this is 6 billion in value. So, and if you look at this, this is returning the remainder of 4. So if we divide 7 by 25, if we divide 25 by 7 rather, we will get 21, which is 3. Then we have a remainder of 4. So modulus only returns the remainder of an operation. All right, so I'll just take this out, take this out, take this out, as we're done with the arithmetic operator. Of course, we can do way more than that, but we'll just keep it basic, as it's simple and straightforward. So I want to keep things concise, move on to the next. Okay. Now, the next thing we have is assignment operator. And what does assignment operator do? It assigns or updates value in place. It assigns or updates value in place. Okay. So you can see we have the equal to sign, which we have seen already when we're looking at variables, and the combination of the equal to sign with the rest of the operators that we have before. Okay. Now, if you remember that in the arithmetic operator, we performed an operation such as this. Now, in this case, we already have an addition and we don't want it to be overwritten. How can we do that using arithmetic operator? So let's just jump into it quickly and see what I mean. So let's say num x equals 50. All right, let's just do num x num y equals 50 comma 15. Okay, so this is what we have, 50 comma 15, and we'll just execute this. So let's use shift enter so we get a new cell jumps out. Code, we want this down so we can add more to it. Just click and then B, escape B, escape B, escape B, escape B. All right, so we have quite enough to work with. Let's jump back to the first one, and yeah, we want to start doing some operation. We want to start performing some operation. So now we can say num z equals num y plus let's say 25, and then we'll print num z down here, num z down here. If we run this, we can just run this, so we get 40. Oh, let's run this and run this. Num y, okay. Yeah, it's strange because my plan was to use num x, so getting 40 was looking weird. All right, 75, so we have 75. And now in this case, let's say I want to update num y or num z. Okay, I also want to increase it by 5. Okay, I want to increase num y by 5. Traditionally, I have to do num z, sorry, I have to do num z plus 5 traditionally, right? So I'll just comment this out. Now, a better version of this will be num underscore z plus equal 5. And this way, we have been saved from repeating variable names. So if I print num z, we should be getting 80, not 75 as we have before. So let's check it out quickly. And you can see in one line, without having to repeat num z as a variable, we have been able to get what? We have been able to get we have been able to add 5 to num z. Okay, so that is what we now have. So all of these operators, they work that way. So what if I want to update it with, currently it is 80, so let's work on num y. So num y is currently 15, it has not been modified at all. So what if I want to say multiplied equals to 5? So I'm saying multiply whatever is in num y by 5 and save it there. So I'll do num y, and this should give us about is it 75? Yes, 75. All right, so we have 75. Let's look at the modulus part. So let's say, for example, num, so let me take this out. Let me just say remainder. So remainder. And then since we have this as remainder, we can say norm y, which is 75 now, modulus 7. Okay, modulus 7. All right, let's do something more fun. Quotient, comma, so norm floor, okay, norm y, floor 7, comma. Let's run this. So run it. Let's print the quotient, and the remainder. So we can say f string as usual. We can say norm y divided by 7 is quotient remainder. Okay, remainder is this. So we just have to close the quotes and then everything is fine. So if we execute that, you see norm y divided by 7, which is 75 divided by 7 is 10, remainder 5, right? You can see how this way of assigning variables we learned earlier is now so cool. So we're able to grab the, now we use floor division, so it's just about thinking of the application. If I had used actual division, it would have taken 7 points, a particular value, right? But because we use floor division, it cuts off the decimal part of it, and then in another way we got the remainder only. So we got the value itself and the remainder separately. So that is how you apply what you learn. You think of ways to use them. Okay, you think of ways to use them. All right, so pretty much you can have fun with the rest, floor, this operation, that operation, and then you do them just like that. So we can now update the quotient and the remainder with some other values as we want or as we please. Okay, so feel free to have fun with that. We'll move on to comparison operators. So I'll take this out and collapse this. So for comparison operator, they compare values basically and they return either true or false. So we have the double equal, we have the not equal. So exclamation mark with equal to is not equal. Okay, we have that in SQL as well. We have the greater than sign, we have the less than sign, we have the less than or equal to, we have the greater than or equal to. So let's just look at a few print statements, probably in just one cell, so that we don't waste much time. We still have other things to do. So we can say 5 greater than 7. So we'll be using formatted string. So 5 is greater than 7. And then we'll say, let's type this literally. 5 is greater than 7. Where's 7? 7 on my keyboard. And then we'll do 5. Right hand. That's the greater than sign. We can just put a colon right here. So if I print this, this should give me false. So that means this is a false statement. So in fact, we can make it better. We can say false statement. Okay, so if we print it again, now it says false statement. Now it feels like a sentence, right? So we can also say very true. If it's true, we say very true. If it's false, we say very false. We say false statement rather. So what about we say 5 is less than, okay? So in this case, we use less than. 5 is less than. And of course, the result of this will be true. So we'll say very true. Okay. Very true. So we'll say very true. Then the other one can be, so we just want to use everything we have here. Equal, equal. So we can say in this case 10 equal, 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 equal 10. Like this. 10 like this, equal, equal 10 like this. And then you can say this will result into a false statement. What else do we have? We have not equal to. So we can say 100 is not equal to 10 exponential 10. 10 exponential 10. Okay, so this should come before it. However, we have something showing an error from somewhere, which we have to fix, because this will not run. So we have an opening, we have a closing, everything seems fine. Opening, closing. Okay, I see it. So there was an accidental closing quote here. So I have to take that out. All right. So I have to take that out that way. So here will be 100 equal, equal 10 exponential 10. Okay, so what else do we have? We want to see, we have seen the less than. Okay, less or equal to. So we can say, I'll leave that up to you. Let me leave that up to you to do, the less or equal to. So let's run this. All right. So 5 is greater than 7. False statement. 5 is less than 7. Very true. You can see how we wrote using formatted string. We're able to blend it as if it were a sentence. I'm saying 10 equals to 10. Okay, I didn't remember to update this part. So let's go back and update it. And it's saying 100 is equal to 10 raised to the power of 10. And this is saying not true. That this is a false statement. Now, we'll isolate this part and see what we have. Well, first of all, let's fix this guy. So 10 equal, equal. Oh, this is supposed to be not equal to, by the way. This is 10 equals to 10 as a string, right? 10 as a string, or actual 10 in word. So whichever we want to do. So in this case, it would be nicer to do 10 as a string, 10 in quotes. Okay. So here we can also say 10 single quotes. So I'll use the same single quote here so it doesn't get confusing. Okay, so this is what we have. Then we're saying 100 is not equal to 10 raised to the power of 10. So that is a false statement. Why? Because 10 raised to the power of 10 will not give us 100. So it is 10 raised to the power of 2 that will give us 100. Okay, so 10 raised to the power of just 10 times 10. So in this case, I'll change this to 2. And I'll say not equal to. So this will result into a false statement. Okay, this will result into a false statement. So let's execute this. And you can see we have false statement, false statement, because these are not true. The only one that is true is what? 5 is less than 7. So these are some use cases of comparison operator. Just some, can be way wicked. It can do way more than this, especially when we combine it with logical operators. Okay, so yeah, feel free to explore the rest that we didn't explore. Write a variable, compare something to another thing, right? Compare names, compare text. For example, we can finally add print. In this case, we won't do anything fancy. So we'll do YouTube is equals to YouTube. And then we should get a false because they're not the same. Say that's a false, not true. Yeah, because strings are what? Case sensitive. Right. So let's collapse that and move on to logical operators. And this is what we have for logical operators. And, or, and not. So we see it says it can combine multiple Boolean expressions. So let's see that in action quickly down here. So I'll just add more code cells. I'll just add more code cells to this place. And then we start with the logical operators, and we can combine, right? Like I said, we can combine expressions. For example, let's start with print true and false. Let's start with that. True and false will give us false. Okay. Why? Because for AND logic, all inputs must be true before the output will be true. Again, all inputs must be true before the output can be true. However, for OR, it only cares about one. As long as one is true, the rest or the output will be true. Let's also add print. So we can say 5 greater than 7 and 2 less than 1. So it will be a good guess for you to think of what the outputs of all of these will be. So let's just run them and see what we get. So the first says false. Why? True and false will give us false. As said, and checks that all conditions must be met. All input must be true before the output can be true. For the OR, both as long as one of the option is true, one of the input is true, the output will be true. Even if we have a million false, false again, or false again, or false again, or true, it will not even care to get to this point. It won't care. As long as this one is true, then everything will be true. So execute that. Okay. So waiting for that. Just a network out there. So you can see that the output we get is what? True. The only time it will check up to this point is if all the previous ones are false, right? It doesn't waste time checking that way, because as long as one is false, the rest will be false. As long as one is true, the output will be true. The rest of the output will be true. Okay. So moving on, we have this, and it says true. So we can say print not true. If we say not true, that will be false. If we say not false, that will be true. If we say not 0, what do you think we'll get? give it a shot. Just think about it. Give it a shot. Think about it. What do you think we'll get? We'll get true. But if we say not 7, we'll get false. Why? When we say not 0, by default 0 evaluates to false in Boolean. Okay, so it's telling us true because we are negating false to true. However, when we did not 7, by default a value evaluates to true, then we get false because we're saying not true is the same as getting false. Okay, so yes, but of course we will still use this in a much larger use case when we probably learn function or we're using conditional statements. We want to check for 2 conditions at a time, but I don't want to bring that in for now. I don't want to introduce it now, and later we can use all of these things, but we have to learn how it works first, and then we can know how to use them in application. All right, so that is that for logical operations or operators. The next one we want to look at now is membership operator. And for membership operator, what it does is simple. It checks if a value exists within a sequence, within a list, a string. No, it's just checking if this is available in something. All right, so does it belong here? That's what we want to see. So let's go to membership operators and write some codes. Okay, so we can say, can we find A in member? A in member. Run that. It says false. What about E in member? It says false as well. What about small e in member? That's true. So it can be as simple as this. All right, we can check let's say some features. Selected features, and this is maybe more in a machine learning environment. So we say I'll just use split. So I can say house ID, SQM, bungalow. That will be a boolean, true or false. We can say rural, just a boolean as well. We have different variables for houses. We can have number of rooms, and say as garden, as pool, and so on. Right, let's assume this is the list of what we want selected. Split. Used features. So used feature should be plural. So we can say we have just this. Then we can say it could be one by one anyway. We can maybe decide to check if a feature is available in the selected feature. But let's use this first. Now say used features in selected features. So let's run that, and it says ooh, false, because split. So it says false. I don't know that. Why? So because we have all of this, I want to check if this is in there. So we'll pick house ID. We'll remove this. So it's in a list now. So you understand? Are you? Yeah, we have house ID. You can also check for another one. You can also check for another one. So what about we work with numbers? So let's say list or number list. number list. We can just do list of range on 10. Okay. Now, what would this give us? Let me print it out for you to see. It's just going to give us a list just like this. Let me print this out as well for you to see. By now, you're already used to, or you should know, the split function, what it does. So we'll do selected feature. All right. So if I run that, you can see this is a list, and that is what this number will also show us as well. So let's just print that out. Number list. So I can say is 7 in number list. So we run that. You can see we get the list of 0 to 9, and it says true. We have 7 in there. What about we check for 13? Check for 13. Oh, it says false. We don't have 13 in there. What about we say not in? That means 13 is not in this list. That will be true. It says, oh yeah, 13 is not in the list, right? So these are a few things we can do with the membership operators. It checks if something belongs to a place, right? So let's look at identity operator. An identity operator is a little bit different, and it's not just what you see physically. Okay, so now let's say in this one it says checks if two variables refer to the exact same object. This is beyond value. Okay, this is beyond value, and we'll see that in just a moment. Identity operators. So I think we have some code cells here. Good. We can use this. We can use all of this, but I want us to use something different. So let's say we have num list 1, and here we have 1, 2, 3. Then num list 2, num list 2 is equals to 1, 2, 3. And then we have num list 3. Num list 3 is equals to num list 1, right? So this is what we have. We'll execute this. And just right there, let's escape the. Okay. So right here, we will now say num list 1 is num list 2. Num list 2. So let's just print them out. Print and num list 2 is num list 3. Num list 2 is num list 3. And finally print. Okay, I copied that already. Num list 3 is num list 1. All right. So what do you think this output will be? So let's run it and find out ourselves and know why we're seeing what we're seeing. So the first one says false, the second one says false, third one says true. But now let's start with the first one. We're saying num list 1 is num list 2. I mean, literally, if you look at it based on values, you can say, oh, they are the same. Okay, so let's make it more spicy. Okay, I'll just take that out, paste it. Good. So let's say equal equal. Then we'll run it again. You can see when we were comparing values, it says it's true, because this is what? Comparison. Comparison. This is true, but this is what? Identity. Identity means are they of the same origin? Let me use the word origin. It's checking, are they referring to the same object? In a simple case, we can say maybe address, right? It's the simple memory address. Are they referring to the same thing? Num list 1 probably has another underlying name, another registered memory address. Num list 2, even though the values are the same, but they do not have the same identity. So that should be clear in your mind. While num list 3 and num list 1 is only referring to the same thing. This is just another name for this. So they are referring to the same exact objects because we did not instantiate. Okay, let me slow down with the English. We did not initiate it with another value entirely. We're only referring to this as well. Okay, now in this case, let me use the word which I hope I can use safely. Consider num list 3 an alias for num list 1 in this case when it comes to identity operators. Okay, and that's why we have false, true, false, true. However, once so far we have been getting just mini milestone exercises. When we're done with the Python basics in full, you'll be getting a series of exercises that will strengthen your hand, for you to practice what you've learned so far. So that is why all those little ones, you should take them seriously. Make sure you put in the work. Don't feel they're too small, because the ones that are not so small are coming. Okay, so but those are just like a prep for you for the ones that are not so small. Okay, so make sure you do them. Make sure you do them and have a good grasp and understanding of individual parts, so that when we use them later in a much maybe bigger concept or in an application of something, you will not be startled, you will not be lost, you will not be confused. Okay, very, very important that you have a good understanding of them. And that's why we're taking it in bit sizes, just bit sizes, units, learning how they work on their own before we combine them in a single full application or to handle a particular task. Okay, all right, so you should be comfortable with what the result right here is showing. If you're not, I would advise you go through this again. Just take this back, listen to it again, and make sure you understand what is going on. Okay, so yeah, this is just the same as what we have earlier. You can just take that out. So this is another good one for, this is membership operator. Let me move it up to membership operator. All right, so it should be in membership operator right there. So identity operator, okay, this is something like that. You can see false. See, same value, different objects. A is not B. Same value, different objects. A is C. Yes, A is C. True, same object. A is not B. Of course, we can use is not as well. Okay, just take this as additional option. So I'll collapse that, and let's see what we have down here. Okay, all right, so identity test if two variables, right? Just comparison, if two variables point to the exact same location in memory. It's as simple as that. While membership test if a specific item exists inside a collection of sequence. So you can see I've already seen something like this already. So that's just a takeaway from this video. And oh yeah, where is our mini exercise? Okay, no mini exercise here, but feel free to return to this place and practice more with some part of this. Pick on them, make sure you get a good grasp of what we're doing. Practice, think of example, force yourself to think of a scenario where you can use them and you apply them yourself. Okay, I will see you in the next video.